Assalamualaikum and hello everyone. My name is Adam Airibe Muhammad Yusof. Today, me and my group will present to you our final report on BITS 1313 Data Communication and Networking. The project is about a UTEM student that want to communicate with the ULAN server at UTEM from his or her house. So there are three main parts of this project that will show you how the student is capable to communicate with the server and what are the steps in order to communicate with the server, like sending or receiving the data from the student computer to the ULAN system server and vice versa. So let us start with the first part, which is the OSI layer model. So we will go one by one layer by one layer, from the student computer to the ULAN system server. So first, we will go from the student computer. So we will start at application layer. This layer will directly interact with data from the user, which in this case is the student. The student data should travel from his or her computer to ULAN system server. Software applications such as web browser are used to initiate the communication with the user to access the system, but it should be clear that software use are not part of this layer. Application layer only responsible to the protocols and data manipulation the software used. And then we will go to the second layer, which is a presentation layer. So, presentation layer primarily responsible to preparing data so it can be used by the application layer, which means this layer are responsible to translating, encrypting and compressing data. Any data entered by the student, for example, username and password, will be changed to bit streams before being transmitted. Encryption will be added to the student's data so that it can secure data privacy. And lastly, presentation layer will compress the data to reduce the number of bits contained in the data so that speed and efficiency of communication can be improved. So that we can go to the next layer, which is the session layer. So session layer responsible for the establishment of communication between the two devices, which in this case are student's computer and ULAN system server. This layer will ensure the session of communication stays open long enough to transfer all the data that being exchanged. Session layer will also do the synchronization, in which the layer will add checkpoints into the stream of data that being transferred. So then we will go to the next layer, which is the transport layer. Transport will take the sender or student's data from session layer and break it into segments before sending it to the next layer. Other than that, this layer will also do flow control for inter-network communication. Flow control will determine the most optimal speed for data transmission to make sure the sender that has fast connection will not overwhelm receiver with slow connection. And then, the segments that has been sent from the transport layer will be broken down into small units called packets in network layer. Routing will also be done in this layer. Routing is finding the best physical path for students' data to reach ULAN system server. And next, in data link layer, packets of students' data will be broken down into more smaller pieces called as frames. And last, before the data sends from the student's computer to the ULAN system server, it will go through the physical layer, the last layer, which is this layer will include physical equipment such as cable and switches for data transfer. Students' data that has been passed down from previous layer will be converted into signals and transmit over local media. So that's how the data has been sending from the above layer, which is the application layer, to the physical layer and go to the area network to be received by the ULAN system server. So in ULAN system server, start from physical layer, it will receive the signal and convert it back to bits and pass it to data link layer as a frame. And data link layer will receive from physical layer, and the frame will be reassembled to packets and then transfer it to network layer. For service network layer, units of small data called packets will be reassembled into segments that will be used on transport layer later. So, in the transport layer, for user's computer, the data has break down to chunks called segments. Now, the segment will be assembled back into the data that session layer can consume. After all the data from student computer has completely exchanged to ULAN system server, the session of communication between the two devices will be closed to avoid wasting resources. That's what session layer do. And second last, at the presentation layer, the data sent to the server are encrypted. So presentation layer will be responsible to decoding this data so that it is readable and the receiving device, which are the server, can understand it. And last, for the ULAN system server, in the application layer, ULAN system server will act as the website that stores all resources related to the educational purpose like HTML files, images, and videos. The server will reply with the content requested. So that's how the process of receiving the data for ULAN system server from the student computer. So in conclusion, modem and sender devices, also the receiver devices, will be used in this situation. So this is the illustration data travel from student's computer into the UTM IT Center. So that's all from me. I will pass it to my partners for the subnetting calculation.
Okay, next we will move on to the subnetting calculations. Okay, first, as we know at Universiti Technical Malaysia Melaka UTM, there are 8 faculty with FTMK, FKP, FKE, FKEKK, FKM, FTKMP, FTKE, and ULEN system server. They are connected to the IT center. In terms of the private addressing SIM, we assume that UTM is class B, which is 172.16.0.0, which is in the range of 172.60.0.0 to 172.61.31.255.255 that we provide to the 8 faculties in UTM. Step 1, to identify the subnet mask. As stated UTM is class B, hence the default subnet mask should be 255.255.0.0, which is in binary, it's this form. Next step is to define the subnet of to be borrowed. Based on the scenario given, we need to calculate the subnetting based on the number of the faculty, which is 8 faculty. The number of subnets should be at least 8, where 2 to the power of 3 is equal to 8, which is greater or same as 8, thus there will be 3 bits borrowed. To calculate the number of subnet masks, since there are 3 bits borrowed, the binary of the subnet mask will be as shown here, which is equal to 255.255.224.0/19. To find the total number of hosts, the number of students of each faculty is within 500 to 1000 students. Therefore, the number of student subnet should be at least 1000 to support, where 2 to the power of 10 is equal to 1024, which is greater or same as 1000. To find the total number of usable hosts, the formula to find the usable host is 2 to the power of h minus 2. And in this form, we find that 2 to the power of 10 minus 2 is equal to 1024 minus 2, that is equal to 1022. And therefore, ULEN system server address will be the 5 available address as the address of the ULEN system server, which is 172.16.224.5. And this is all the subnet of each faculty, the network address, usable host range, and broadcast address of each faculty. Okay, next we move on to the TCP/IP setting manual. TCP/IP setting manual is a step-by-step manual on how to configure the IP address for the ULEN system server. For step 1, we will show the IP configuration of the computer. To display all the current IP configurations, type in ipconfig/all on the command prompt which obtained from the DHCP server. This is all the figure 1 and figure 2. Step 2, type in ipconfig or release to release the IP address that have assigned from the DHCP server, which is shown in the figure 3. It shows that this computer has no longer have IPv4 configurations. Step 3, to manually assign TCP or IP address, open the control panel as shown as figure 4 at the network and internet. At the network and internet, click the view network status and tasks. After that, click change adapter setting to display all the network connection. Step 5, the next step is right click on Wi-Fi and choose properties as shown as figure 6. We click on Wi-Fi and choose the properties. For step 6, figure 7 shows the Wi-Fi properties pop-ups. Then select item Internet Protocol version 4 IPv4 and click on properties button. After we click, figure 8 shows the new IP address subnet mask, default gateway, and DNS server of UTM network. Type in the IP address which had prior to release the IP address that obtained from the DHCP server. The subnet should be 255.255.0.0, which is class B, and the default gateway is 172.16.224.1, and the DNS server of 172.16.224.1. And this is what we obtained. For step 8, type in ipconfig to display the new IP configuration as shown in figure 9. At this time, the DHCP enable is no, meaning that it have manually set an IP address. That's all from our data communication presentation. Thank you.